Okay, so let's talk about Euclid's Book 1, Proposition 6. If in a triangle two angles be equal to one another, the sides which subtend the equal angles will also be equal to one another. So what he's trying to get at here is that if you have these two angles, F and G, congruent, there is no possible way that the sides corresponding to the segments FJ and GJ cannot be congruent, or there's no way you cannot have an isosceles triangle. You will always have an isosceles triangle, is what Euclid is trying to show with this proposition. And by carrying it out, he decides to say, assume you have not created an isosceles triangle. You're in imaginary land, you somehow did it. So we're going to lop off an amount of one of your segments, it doesn't matter which one, you pick yourself, that is enough to make it equal to the smaller segment. So now that I've lopped off JK of the segment FJ, we can say that this FK is congruent to JG, our given, it's our assumption that we did it. And so we're going to mark that to be congruent. And we should also go ahead and state that FG and GF are going to be congruent to themselves since it's the same segment. So give that a mark as well. Now to move forward with this proof, we need to create a second triangle, one that's supposedly congruent to the other, and observe what we've made now. So the triangle KFG should be congruent to the triangle JGF. And yes, because of side angle side, we're using our proposition 4. I almost spaced out for a minute there and got lost in this small little construction because it's mind-boggling sometimes for me but to do. But when we do this one, we need to point out that we're using side angle side, one of the propositions we just did. And to move forward with it, we're going to have to state that the segment JGF, okay, GK should be congruent then to JF of this triangle. Yes, okay. But if that's the case, since the angle JGF is congruent to the angle, or excuse me, the angle KFG is congruent to the angle JGF, then this KG is going to be congruent to the base. Oh, don't mess this up. JF. And therefore these two triangles are congruent. However, as we stated earlier, JF is not congruent to JG. So there are no way with this new side created that these triangles can be congruent to one another. And so we're saying that now that we have a smaller triangle is congruent to a larger triangle, or that a larger triangle is congruent to a smaller triangle. So that's absurd, and it just doesn't work. And that's what Euclid used to show this, which I think is pretty slick. But thank you and have a good day.